Hello and welcome to the first JavaScript lecture. We are done with the server side and with the APIs for the time being, so we shift our attention towards client side. But before we can do that, we need to revise the JavaScript language. A few words of motivation. At the server side, we've revised the PHP language. However, it's not that important that you actually know PHP language to be a good web application developer. You have plenty of alternatives to PHP like Java, C# or Python. However, at the client side, you are bound to this one doom, JavaScript, which is actually the only language currently being used at the client side. Yeah, actually there are some variations of JavaScript. There are some dialects like TypeScript or JSX. However, all these languages are derived from JavaScript. Before we get started, I would like also say a few words about the outline of this lecture. At this point, I assume that you already know JavaScript, at least some JavaScript fundamentals. Nevertheless, I'm going to revise the most basic principles, and in some of them I'm going to dig deeper. This lecture is focusing on ECMAScript or JavaScript 5, so a very old dialect which is not currently used. However, I think since you already know the JavaScript, I think it's better to start with the older dialect because it's easier to explain some internal principles and concepts that JavaScript holds on in this older dialect. The next lecture will be focusing on the novelties of ECMAScript 6 and all the subsequent ECMAScript versions which are now current. I would like to start with something very fundamental, how JavaScript treats values and data types. JavaScript is a dynamic weakly typed language, which means that it treats values and their types in a somewhat jovial way. First of all, it separates values and variables, so basically value is anything that's yielded from an expression or read it as a literal. And these values have attached data type, so that's the first important thing. The data type is attached to a value, not to the variable. And there are only few data types in JavaScript. Noted that there is only one data type representing a number. This data type is basically 64-bit floating point number, and it's also used to represent integers, meaning we don't have a full precision of integers. 32-bit integers can be represented in a 64-bit float without any problems, but larger integers might get imprecise, so you have to be careful about dealing with numbers in JavaScript. Then we have basic types like string and boolean, and the most important type perhaps in JavaScript is object, because almost anything is object. Also note that a function is a data type because we have first class citizen functions in JavaScript. And instead of null or empty data type, we have something called undefined. Don't mix up with null, because null value is also valid in JavaScript, but it's not undefined. We have operator type, of which can determine the type of any value which is passed into this operator. Values are automatically garbage collected when no longer needed, so unless you attach a variable to a value, the value itself is automatically garbage collected. The most difficult thing about JavaScript is that it performs many type conversions automatically. And the second problem is that it overloads some operators in a not very nice way. So for instance, we have this plus operator, which is both used for string concatenation and for arithmetic additions. Unlike PHP, where string concatenation have specific operator dot, here plus is used for both, which means sometimes it gets somewhat ambiguous. So we don't know whether this expression actually performs addition or concatenation. I can tell you, and you also see from the result, that in this case it will perform concatenation. The explanation is rather simple. Converting a number to a string is considered to be a safer operation than converting a string to a number, so it chooses the safer path, cheaper path, so it converts this number into a string and then it concatenates these two strings together. On the other hand, if you replace plus with something else, like asterisk, meaning the multiplication operator, unlike in Python, is used only for arithmetic operations. So in this case, it will force the first argument to be casted into a number, and then these two numbers are multiplied. So the result is 20 as a number, not as a string. The typecasts become even more profound when dealing with simple comparisons. This is one of my favorite representations of the mess in the data types and their juggling. So it somewhat makes fun of Christianity. So it compares Christianity to JavaScript timecasting. As you can see, if you compare empty array, string holding 0, and string holding arbitrary white space, these three things are not directly equal. Obviously, empty array is not equal to the string that holds 0, but all three things are equal to numeric 0, to number 0. So all these three things can be compared with 0, and the result will be true if you compare it for normal equality. Variables in JavaScript are somewhat different to other languages. If we tend to think about variables as memory boxes, so for instance in C++, if I have an integer variable x in a local scope, then I also assume that a memory has been reserved for this particular data type on the stack. However, in JavaScript, variables are rather attachments to values, so they don't allocate any memory, they just mnemonize the reference to a value. Unlike in PHP, variables in JavaScript are declared using var keyword. In the more modern JavaScript versions, we can use also const or let keywords, and this keyword is used in either global or local scope, so we can create a global variable or local variable. Global variables are also somewhat different because the global scope is directly mapped to something which is called the script environment or the execution context of the script. In the browser, this execution context is represented by the object known as window, and the global variables are directly mapped to its object, meaning if I create a global variable, it's the same thing as if I create a property with the same name inside this global object, inside this universal environment object. Local variables are also somewhat strange because local variables employ functional scope instead of classical block scope, so a variable inside a function is visible in the whole function, not just in the block where it was declared. So it's another difference to other C-like languages. The most important data types in JavaScript are objects and functions. So let's start with objects. Objects are not traditional instances of classes. Instead, they are just simple unordered name-value collections, and all their members are public, so they're more like dictionaries or hash maps. Objects are constructed very easily. We just simply write the contents of the object into curly braces. Note that curly braces are in this context somewhat overloaded because curly braces also represent function bodies, and they also represent blocks of code that can be used in regular statements. So be careful where and how you write curly braces. As you can see, the contents of an object is a simple name value list separated by commas, and since the JavaScript is so dynamic and the object may hold regular values like numbers or complex values like functions, thusly creating methods in this manner. Objects are also dynamic, meaning you can alter the contents, alter the properties after the object is created, so this will basically create another property named another foo inside the same object. Just insert another property into the collection. Objects have no classes, but to provide at least some inheritance functionality, JavaScript introduces prototyping concept. Prototyping means that every object may have another prototype object. The prototype object is referred using internal prototype property. Actually, this property is not visible, it's not enumerable, it's hidden inside the object. It cannot be directly accessed, but we can access it via, for instance, object get prototype. So we can access it using a specific function. Prototypes simulate classes in a very specific ways, which might be better explained on an example. So let's say that I access a print name property for reading, which is a part of my object. It's a variable that holds this particular object. So in this case, print name property is searched in this object. Obviously there is no print name property, so what happens is that the prototype chain is followed over here and the print name is looked up here. We found print name over here, so this is the value which will be used in this expression. The parenthesis suggests that the print name here holds a function, so a method will be invoked over here. So this is what will happen if we just read the property. It searches the prototype chain upwards and find the first matching name for the property. If we try to write into a property, what would happen? So in this case it's very simple. No prototype chain is followed, so in this case a new member will appear over here in the my object itself. This behavior is let's say logic in some sense, because if the prototype chain were followed and the name were changed in this case, it would mean that this name will change for all the objects which hold the another object as a prototype. So in this case, if the another object should somehow represent a class for all these objects, then it would mean that we just modified the class for all the objects, which is not probably not the intended behavior. On the other hand, if we create a new name object over here, assuming that this name just holds some default value, then next time my object name is read, then the name will be found here and the prototype chain will not be followed here to the default. So it's a kind of logical behavior for the prototypes. So let me give you an example how prototypes are used instead of classes. So in this particular example we have this object called circle prototype. Yeah, it's a normal regular object. It's just our convention that we call it prototype, and this object actually plays the role of a class. The object has two properties. The most importantly, it has this circumference. It's a method, so it's basically a function inside a property, but it's kind of a method. It will play the role of a method, and we place this default value for a radius here, just to be sure that this value is always here and it's always a number. So if the property is missing in all the actual objects, it will be always read as a number. So creating a new object which should be a prototype of this circle prototype is very simple. We just use the object create. It's another way how to construct objects, and this way we can specify the prototype. So this value will be set into the hidden prototype property of this newly formed object. Now we can fill in the data, so by setting circle radius, we are setting the radius property, but not to the prototype of course, but just into the circle object. And now we can call circle circumference, since this works in a particularly awkward way, so that this will actually be fed, the value this will be fed the circle object. So in this case the circumference will actually compute the circumference of the newly created circle, which will actually yield this particular value. Another example could show us how to deal with inheritance. So let's say that we have a small hierarchy of classes. There's the base class and a derived class, and then there's an object of the derived class in some regular class-based language like C# or Java. So in JavaScript we actually need to have a object, my class, for which should represent something like the my class. In the regular language, the foo property of course is pointing to a function, so it acts as if it was a method. Then we create another my subclass object. We need to create this one with a specific prototype, so we need to create this object in a specific way, and then we fill in the bar property, again attached to a function object. And finally, if we want to create objects, regular objects, then we just create another object which uses my subclass as a prototype. So as you can see, there is little difference between defining a subclass and between instantiating an object. So this is how the prototype chain works. And the most distinguished difference between these two approaches is that you need to remember these are still objects, so you can augment them, you can change them at runtime, meaning even if you have an object that has a specific function or method, for instance, you can alter this behavior at runtime by replacing this or this property of the prototypes of this object. There are a few technical details you should be aware of. The first one I would like to point out, the pretty obvious one, is that there are two ways how to access properties of object: the regular way you've already seen, and an equivalent way which simulates arrays, so you can use brackets and then place the name of the property as a string inside. This approach allows us to represent arrays as objects. In fact, an array is a specific object with few sugarcoating and some specific properties, but basically array is still an object. And secondly, if we need to use properties which have names that cannot be easily placed in regular syntax, so cannot be placed here as a regular identifier. For instance, if you have a property name that has a dash inside, that dash would be in this syntax represented as a regular minus sign inside the code. So we need to use this approach and place the property name here as a string, and you can use almost anything as inside the string. Second thing, these properties are not, this is not the only way how to assign or how to define properties. There is also a more complex way. We can use the define property method. This specific method gets the object to which the property is being assigned, the name of the property is a string, and finally a complex descriptor, and this descriptor defines many features of the property. For instance, we can specify whether the property would be enumerable, meaning whether this property will be visible in the keys, whether if we iterate over the object keys we see this property. Also, we can define a read-only properties, and we also can define fake properties which actually don't have any actual value but uses getters and or setters instead to get and set their values, so we can use much more complex representation for properties. A bit of advice here: if you're doing something with getters and setters, be careful with that, because sometimes it tends to, let's say, tempt the programmers to define properties instead of regular methods. So every time you try to define a regular method and hide it, disguise it as a regular property, don't. It's better if it's normal regular method, and use these only for specific properties that needs to be calculated dynamically, for instance, or need to be checked upon setting. A good example of such a property would be a thing like array length. So this is a property that needs to be computed dynamically. However, it's a good idea, it might be a good idea to keep this as a regular property, or at least give the appearance that this is a regular property. Let me give you an example how the define property can be used. So in this example we have a regular plain old object which has one regular isDone property, so possibly this object represents some sort of operation that is completed sometime in the future. And second property is defined using the specific define property approach. This property is called progress, and it's a fake property because it's using getters and setters, so it's actually represented or wrapped in these two functions, but it only translates to a regular private property progress. So actually it creates an internal, well, not internal, but it's prefixed with underscore, so kind of a private property progress where it stores its value. And when the value of the progress needs to be fetched, it returns the name of the progress internal progress variable instead. When the variable is being assigned, it gets a new value. It provides some checkings and some casting. So first of all, it casts the value to a number, and it makes sure it stays, this complex set of two expressions just makes sure that it stays within the 0 to 100 range. So it's probably a percentile progress. And also if the progress exceeds, actually this checking makes sure it won't exceed, but if it's equal to 100, then is done is set to true. Actually, you can see it's actually setting the is done flag according to this expression. So it's if the progress is less than 100, it again sets is done to false. So if we have this object, then we can set the progress property as if we are assigning a normal value to it. But as you can see, if we read it later, if we try to reach the previously written value, we get a slightly different value. We get only 100, and also if we check the is done property, it will be set to true despite the fact we didn't change it directly. Besides creating, let's say, unusual properties with getters and setters, we can also do something about the whole object. The simplest thing you can do is prevent extensions, which will prevent adding new properties into the object. We can also seal the object, which will actually prevent adding or removing properties, or we can freeze it altogether, so we can prevent any property modifications, including assigning new values to any of the properties of this object. Yeah, the real question is whether this is really necessary. So yeah, in some specific scenarios when we are using some libraries, this might be useful, but remember, this is JavaScript, so, and we are all consent adults here, so this is maybe unnecessary, because if you want to do something, if you want to make an object private or something like that, you can just use some conventions or just provide sufficient commentaries to your code so that no other programmer would actually need to modify your object. Second but no less important data type I would like to focus on are functions. Functions are in fact a special value in JavaScript, so they are not merely constructs of the language, but they are dynamic, so they are created dynamically and they act as values. In this hierarchy, we call these types of functions the first class functions. Normally second class functions are the ones that you are used to in other languages, so these are functions which are created by compiler at compile time, but you can still do things like take pointer to these functions and call them indirectly. Then there we have third class functions, and those functions cannot be even called indirectly. So in this case, functions are created dynamically. There are three ways how to create them. Actually, I start with the third one. This is a very old way how to do this, and I'm just mentioning to make the set complete, but this is a very bad way how to create functions, because the body is actually passed down as a string and evaluated as a string, so it's a really bad idea to create functions this way. The first two ways how to create functions are almost identical. I said almost because actually there is one difference I would like to mention right now. The declarations of functions, the declarative approach, the first one, is actually slightly more different, because these functions are processed at parsing time. So when you declare function like this function is processed at parsing time, so it's visible in this context from its top. However, this function is created at runtime at the point where this assignment actually takes place. I will explain in more detail on the following slide. Yeah, and functions, since they are basically dynamic, so they are also variadic, and also there is no technical difference between functions and methods. So when I'm talking about methods, I'm just emphasizing that that's a function which is actually assigned to a property of an object. So in this slide, I would like to explain the difference between the traditional function declarations, and assignment to a variable. So at the end, both these constructs basically create a variable with this name, with these names, and this variable holds a function. The difference is that the first construct is being hoisted, meaning that it processed at parsing time, so the declaration and the assignment of this function to the property to the variable foo will actually take place at the parsing time. Meaning, if this is the normal code, then calling foo over here, meaning above the declaration of foo, will be okay, because first, before this code is executed, it's first parsed, and since these functions are hoisted, since these functions are processed at parsing time, the foo exists over here, so it can be called without any restrictions. It's already known. If I try to call bar here, it will actually cause an error, because this construct over here will be parsed in the during parsing time, so the variable bar will be known. However, it will be initialized at the top of the code. So over here, bar is still undefined, meaning it holds undefined value. So if you try to call bar over here, you are basically trying to invoke a function on an undefined value, which obviously caused runtime error. Having functions as first-class citizens have some implications. Perhaps the first implication is that you can nest function creation, so you can create functions inside other functions. Actually, this is true in other languages. For instance, in PHP, you can also create function, declare function inside another function. However, in PHP it's a, let's say, bad practice or a very special technique. In JavaScript that's perfectly normal. Also, there are other differences. For instance, and the visibility of local variables. As I said before, JavaScript has a function scope of local variables, meaning that if I declare a variable inside a function like this one, for instance, then this variable is visible in the whole scope of the function. Well, in this particular case there is no difference, because there are no other nested blocks inside the function, so yeah, there is no difference between the function scope and block scope in this particular slide. However, what I would like to point out here is the visibility of outer functions and outer scopes. So in this manner, if you declare a function inside another function, like this inner foo inside a foo, the inner function does not see only its own local scope, but it also sees the scope in which it's created. So if I create inner foo, this function has access to the parent's context, so it sees a2 variable and also its parent's context, so it also sees global variable. However, seeing global variables may not be that surprising in this situation. If I even nest this deeper, like 3 levels, then this expression will actually look up the appropriate variable, in this case a2, in the scope chain. So it travels all the scopes upwards and finds the nearest variable that holds this name and assign the value into this variable. Now you can see that there is a difference between just assigning value into a variable and declaring a variable, because declaration actually creates a new variable in the current scope, whilst assignment will travel the scope upwards. And actually, if a2 won't be found here, if a2 won't exist in any of these scopes, it will be created at the global level. So at the global level, a new variable will be created. So basically, this is not a good idea. This is not a good way how to create new variables, because they will surprisingly be created at top level, at global level, which might be somewhat confusing. So here I would like to dig a little deeper into the details where actually the variables live. The JavaScript defines something which is called execution context, and this execution context is a kind of a container where the variables actually are. A good abstraction is that this context is something like a hidden invisible object which holds the variables as if they were properties. Although the JavaScript specification, the ECMAScript specification, doesn't say per se how this should be implemented. It stands for reason that that is implemented using a similar principles like the objects, although they have to be some modifications made. This goes well along with the concept that the global context for the global variables is actually an object. In this case, it's not an invisible object. You can touch that object because the self-reference is mapped to that object, so a global variable exists. It's a funny thing with a self-reference. The window object holds a window property that points to itself. So this window object can be accessed as a real object, so you can actually touch it. The context is modified every time function is called. Actually, it's somehow augmented. In normal languages, when function is being called, a new frame is allocated on the stack, and all the variables, all the arguments of this function live on the stack. In here we still have stack, but on the stack they are not normal frames, but they are execution contexts. And the execution context isn't there by itself, but it forms a chain, so it's slightly more complicated. So actually we are not talking about one object that holds the context, but this object may have a predecessor in something called scope chain. So the predecessor is similar, the scope chain is here, the predecessor is similar to prototype in the regular objects and their hierarchies. So what actually happens when a function is being called? First thing that happens is that an activation object is created. Yeah, it's even called object in the documentation, so it stands for reason. It's a very similar concept to a regular object, and all the data necessary for calling the function, especially the calling arguments, are loaded into this object, are set in this activation object as properties. Then, and that's perhaps the most difficult part, is that the scope chain has to be selected, but it's selected from a hidden scope property of the function object, so of the function which is being invoked. The function actually holds its own execution scope or scope chain alongside with it. So it's a very important thing for dynamic language like JavaScript. So the function actually defines the scope in which the code will be executed. And then the activation object is pushed at the front of the scope, so it becomes the first object in this scope chain, so the most important one where the most relevant data are. So as I said before, the scope chain is somewhat like a prototype chain in objects. However, there are some differences. The most important difference is that both reads and writes follow the chain. In the normal prototype chain, reads follow the chain, but writes are made directly into the front object. So this is a huge difference. The writes also need to follow up the chain, so appropriate existing variable is determined and updated. If you want to create a local variable, meaning the variable in the front object, in the foremost object, you need to declare it using, for instance, var keyword. So this is a piece of code that should demonstrate this. Let's say this is on the top level, so this is like on the global level, meaning that this variable a is actually a global variable, and this function foo is declared at the top level. And when I invoke function foo, this is what happens. So first of all, the activation object will be created, and the activation object holds all the variables relevant to context of foo. This regards the arguments, so the x has to be in the activation object. Since it was invoked with value 3, the x variable is also initialized with this value, and also a b variable is determined by parsing already, so b variable will be undefined but present in this activation object. Of course, b will be filled as soon as the code reaches this particular line, so b is kind of prepared in the object but not initialized yet. And the activation object is pushed at the front of the scope chain, but the scope chain is determined by the scope hidden property of the foo. And since the foo function was created at the global context over here, then the its scope actually points to the global context, meaning to the global variable, if this is inside a browser, to the window variable. And this variable actually holds all the global things like a. It also holds foo, because foo is identifier like every other. It only holds a function, and it also will hold a variable c, which is actually created over here. You can see that c does not have any declaration, meaning that when I write to c, the scope chain is followed up. So we need to find the nearest c, and when we reach the end of the scope chain, to the last object in the scope chain, we have no other option than to create the variable c inside this object. So actually c will be created at the global level. C will be created as a global variable. As I mentioned before, this is not a good idea how to create global variables. This is just what will happen, but don't use this in your regular code. In this context, we need to define another term which is called closure. You have to realize that when a function is created, it captures its current execution context at the time of creation into the specified internal secret property scope. So actually the function remembers the context in which it was created. Normally that's no big deal, because if you have a top level functions in a global context, they just remember the global context and nothing interesting happens here. However, this becomes interesting in cases when you create a function inside another function. So if you create a function inside another function, the internal local execution context of the outer function is saved to the scope, so the newly created function will remember it. And if you yield this newly created function outside of this scope, for instance yielding it as a result variable, which you can do easily since functions are first-class citizens, then this scope will cease to be accessible from anywhere else but the currently created function. So by defining nested functions and returning them out of their original creation scope, you basically create a hidden execution context which is native to this function only. So it's visible only when you invoke this particular function. In general, this technique is called closure. So sometimes the closure refers to the isolated scope chain which is not accessible directly but only by invoking a function. But normally, technically, we call the closure the technique when you create functions actually where the functions hold their execution contexts alongside with them. So it's the way how to store the execution context inside the functions when they are created. I will try to explain the closure once more on example. So in this case we have a make function which is here just to create the hidden execution context. The make function holds one local variable x, which is local to make, and it creates and returns another function which is nameless because it's immediately returned as a value, which actually uses the x. So the x here is actually the x over here because the function can see the outer scope. The function itself can see everything that happens outside, everything that was declared outside this function. So in this scenario, first thing we will do is to call make, and we save the function created inside the make into some variable. Okay, what will happen in this case? When we are invoking function, we know that activation object is created, and this activation object is filled with variable x. It has no argument, so the x will be the only variable in this activation object, and as the make is invoked, it will hold the value 1. This is the initial value that will be filled as the make function is invoked. Then this function is created and yielded back, stored into f1 variable, and it will hold the pointer to the reference to the scope in which was the function created. Since it was created inside the make function, the scope will point to the activation object of this particular call. When we do this again, so we call make one more time, and save the result into a different variable, the same thing will happen. So another new activation object will be created. This object will also have variable x initialized to 1, and the newly created f2 function will capture this newly created activation object as its scope. So now, if we try to invoke f1 function with some particular argument, of course an activation object is created. Since this internal function has no local variables but it has one parameter dx, this parameter is initialized in the activation object and passed down to the function. When the function is called, it uses its scope property to fill in the scope chain, so the activation object itself is prepended to this particular scope of the function f1, and thus it can see all the variables inside the whole scope chain. So for instance, it can see variable x inside this prior object of the scope chain. So if we perform some operation like x is added the dx value and then the whole result is printed out, then the x will hold 4 after update and 4 value will be printed out. Then later, when we call f2 with a different value, the same thing will happen, but on a different scope chain. So again, activation object with dx7 will be created, and the activation object, the scope, is taken from another function, so we will follow this chain instead of the first one, and this variable x is updated instead of the first one. The closures are not in JavaScript by accident, they are there by design, so they're used for many useful things. The first example, you've already seen that, so it's like I've just rushed through it, is to create binded parameters within functions. So in this case, I'm creating an adder function with one parameter fixed. So in this case, when I create adder with value 3, this is a function which will always add 3 to its arguments. The same thing if I've created with 7, this is a function which will always add 7 to its argument. So calling the first function with 10 yields 13, and calling the second function with 10 yields 17. We can generalize this principle, so for instance we can have a universal binding argument function which gets another function as an argument and the data that should be binded inside, and it yields another function which provides the data bounded over here as an argument for the internal function. Actually this is just an example how the closures are used. There are many already existing functions like these, for instance the function bind, which is a built-in function in JavaScript, so you don't have to really implement this on your own, just to give you the impression how it works inside. Another application of closure is to, let's say, hide private functions or some private functionalities that needs to be kept out of the harm's way. Again, we are in JavaScript, so maybe there are better ways how to deal with this. I mean, setting up some conventions, but if you really need to hide some stuff from the programmer, then you can use closures. In this case, we are using a nameless function to create a closure. These variables and this local function are meant to be used only inside the execution context of this function. So this is the hidden stuff which shouldn't be accessible from the outside, and what's returned outside is this function which actually is the interface for whatever is inside this hidden scope, and this function is kind of a lookup function that uses the internal find pattern function over here to find something in this lookup table. You may note that we are not naming this function that creates the execution context, but thanks to these parentheses and thanks to these parentheses, the function is actually immediately invoked and then forgotten. So the only thing which is remembered is what is being yielded from the function, and that's saved in this searcher variable. So this is kind of a more complex way how to create a function, because basically this searcher holds just a newly created function, but this newly created function has access to this hidden stuff in the extra execution context of the outer function. Since this closure context is somewhat difficult to grasp and sometimes it's not correctly wielded by the programmers, I would like to share a few pitfalls, examples. I believe you've already seen this one. It's called shared context. So in this case we have this create links function which is supposed to create 5 hyperlinks and equip them with a callback function for the onClick DOM event. This onClick function is supposed to, let's say, behave slightly differently for each of these links, so it's supposed to somehow print out or alert the index of the link. So assuming that I is the index of the link, it's supposed to work slightly differently for every link. However, all these links are created in the same scope, in the same execution context, meaning that they share this variable I, meaning that the I will be always the value which is present at the last when the scope is closed, when the scope was actually completed. So the onClick function will always print 6 because 6 is the value with which the I ends after going through this particular loop. Another pitfall is called accidental closure. It's a case when you create a closure but you don't really intend to, you don't really need to, and these closures may increase your memory footprint. In this case, in this scenario, we have a function called addLink handler, and this augments given link, so it's expected to be given a hyperlink, and it attaches a new event handler to this particular link. In this case, a new function is created over here which just augments the link, and that's it. So seemingly this seems perfectly fine. However, it's not completely fine because this function, the handler itself, does not require anything from its parent's context. So it does not require any variables or any arguments from the addLink handler context. Thus it does not have to carry this context alongside every time the onClick event is triggered. So yeah, there's no big deal because actually there are no large data inside, and we assume that the link to which this onClick handler is attached is still existing, so you're not accidentally preventing any garbage collecting in this case. However, if this function will hold inside here some more serious code which actually creates some data structures which are supposed to be evacuated, garbage collected once the context is dismissed, then it might cause some grief because these structures will be still kept in memory because they are accessible through this hidden closure. The final example of a pitfall is not actually a pitfall of the closure, but pitfall of the behavior of the scope chain, and it's a pretty silly one. However, I've seen this so many times I've decided to include it on the slide. So in this case, beware of the names of the parameters, because if you name the parameters in different contexts which are both visible in the same, then this value will actually override this value. This will be present in the activation object while this is present in the another object of the scope chain, so this one will take precedence. So in this case, presumably this should be incremented, and this parameter which should be incremented is this one, otherwise it makes less sense. However, somebody accidentally placed the same parameter name as an argument over here, so this local parameter will be incremented and this value will not be modified. Yeah, as I said, it's pretty silly. However, I've seen this naming collision so many times. The main reason is it's easy to lose track of the names when you're dealing with nested scopes and nested context, so be careful when you're dealing with these because it's easy to lose track of names. There is one peculiarity about the scope chain I would like to share with you, and that is that you can actually manually override, manually augment the scope chain yourself. You can use a regular object, and using the construct with object statement, you can actually push this object to the active scope chain and execute this statement or block of statements possibly using this object as the front object of the scope chain. So basically, if we have any object like this one O here and we push it like this to the scope chain, then this code will have access to variable x as if it was a normal local variable, so I can even hide it in some scope chain of a newly created function. So I can really augment what's being hidden inside the function scope chain. Nevertheless, this is, let's say, very unorthodox, and don't do this in your regular code. This is just a mind teaser to let you know that this is actually possible, but please do not use this in your normal regular code. Last thing that remains to be explained is the behavior of methods. Actually, as methods I still mean functions inside object properties, but there is one strange thing about these functions, and that's the behavior of this keyword. And by this I mean the keyword this. So what happens if I have this used inside a function body? If this function, actually method, because it's a function inside an object, is invoked, then this is replaced with the object on which the method is actually invoked. So if I use it on this object, then this object reference will actually be passed down to this keyword inside the invocation of the method. This behavior is particularly useful if you're dealing with inheritance, so it's very convenient that you can have this function placed in a prototype and then inherit, meaning derive prototyped objects from this prototype. However, it sometimes causes slight grief when you need to pass down a method as a delegate, as a function, as a callback. So for these things, you can use binding. You can, for instance, bind different this or actual this to a particular method and thusly create a delegate. So for instance, if I use function bind and I place this as an object this inside, then a particular object is bound to all these instances, and the newly formed delegate will be always called. So this keyword refers to this particular object. Even though ECMAScript 5, which was used during the whole presentation, is now considered somewhat old, there are even older dialects of JavaScript. I find it interesting to demonstrate how the JavaScript evolved over the time. However, this stuff is really old, so if you're not that interested in, let's say, JavaScript archaeology, then I might suggest you can skip this part of the video. So if you'd like, you can fast forward. All these slides regarding this old school JavaScript prior to ECMAScript 5 are labeled old school, so you can easily recognize them. So you can fast forward if you'd like. So if you're hearing this, you haven't fast forwarded, and let me tell you a story about how this all began. So in the past, before the JavaScript actually admitted it's a prototype-based language and that there are no classes whatsoever, the role of classes was somewhat supplemented with something called constructors. A constructor is otherwise ordinary function, so it looks like ordinary function. It's defined as an ordinary function. The only difference is that we are using this keyword inside this function. So it's a function which is supposed to initialize a new object, and this refers to a new created object that should be initialized. Actually, constructors have prototypes hidden inside, but they didn't expose them very much, so there was this prototype property inside the actually constructor object. Remember, this is actually a function, but function behaves in the JavaScript almost like object. It has its properties. So this function has a property prototype, and the prototype can hold an object which is later assigned as the prototype of the newly created object. So don't mix up the prototype property, which is normally accessible, normally augmented of the constructor, and prototype, the hidden property prototype of any object. We can augment this prototype, of course, so we can, for instance, fill some methods to this prototype, we can replace it with another object, no problem there. And finally, new objects were created using new keywords. So this was much more like a regular language, regular class-based languages which have new keywords, and the new uses the name of the constructor as the name of the class. So the constructor somehow supplemented, at least ideologically, the class. Although at first glance this was slightly more convenient because we have some kind of entity that represented classes, and this entity was different than a regular object, well, at least ideologically, it actually causes some complications, especially when dealing with inheritance. So we have this same example as we had before. This is some example from a regular based class language. So we have a class and a derived class and an instance of this class. In case of JavaScript, we need a constructor function for each of these classes. However, each constructor function is also associated with prototype object. So the prototype chain is still there. The prototype chain was still present. There is no difference there. It's there from the beginning. However, for creating classes and for creating the appearance of inheritance, we had to use slightly more complex approach. So if we wanted to create a my class, we just created a prototype which was filled with an empty object. We could have augmented this empty prototype object, for instance, to assign methods to this particular class, and then when we need to derive this class, create a derived class like subclass, we simply need to create a new class constructor, so a new function, and then create a new object of the old class, of the old my class, and this new object we assigned into the prototype property of the newly created constructor. So basically we need some sort of a representative object which is created old style, normally using a new operator from one class, and this object is used as a prototype for another class. And then when we normally use my class for instantiation, again using a new operator, then we can use this object as a regular object, and still this object will have prototype copied from this prototype, so the prototype will point to this object, and as demonstrated earlier, this prototype will point to this object because it was copied from this prototype. This is somewhat strange in the sense that it mixes up instantiation of objects, which is supposedly done using the new operator, and prototype chaining, which uses the same mechanism. You just need to create a new object and then assign it to a prototype property of a constructor. So the mechanism is still the same, however it's slightly more confusing, slightly more awkward in the sense of coding. One of the main drawbacks of this approach is that it leaves so many questions open, so there are so many possibilities how to approach to the classes implementation. The constructor concept suggests that the whole initialization of the newly created object should take place inside the my class, the class constructor, in this case my class. It has some advantages. For instance, since this is a function, it has its own execution context, so the privacy can be achieved by a closure mechanism. On the other hand, it's not very pleasant because everything is instantiated here, meaning that also methods are always recreated for every object over and over again. So it's possibly not the best way how to deal with things, especially from the memory footprint point of view and also from the performance point of view. So the first choice we have is just to place the methods, at least the public methods, outside, so we can augment the prototype object of the my class and provide methods, save the functions as properties that holds the methods. So this way this function will be created only once for all the instances for all the objects that will be instantiated from my class. However, there is another drawback. This global method, this public method, does not see what happens inside this execution context. So in this case, it can be shared, but it cannot access the private members, the private methods, because they are hidden in the closure of the constructor. We can deal with this by separating the methods, the public methods, between normal, regular public methods, which are created only once, but they cannot, as I said before, they cannot access the private members, and privileged methods, which might have a greater overhead because they are recreated all over again with every constructor call, but they are created inside this context, so they can access the private members, which are hidden in the constructor execution context. Also, the class inheritance can be implemented in several ways, of course using prototype chain. So the most straightforward approach would be to simply create one object and place it as a prototype of another constructor. So in this scenario we have this person class, meaning a constructor, which actually creates objects of a person type. It has one method, so its prototype has registered one property that acts as a method, and this is a register hobby. And then we would like to create a derived class which inherits from person. This class is called student. So what we do, we create a student constructor, and then we place a new person as an instance of a prototype of this student. Then we can augment this object. Remember, we are directly augmented object of a person, so we are modifying the properties of a person to add, for instance, new method that will be usable for the student. The slightly awkward thing here is that this is both a regular object of a regular person, and both it acts as a prototype for a student constructor, so, or student constructed object. So it has a somewhat dual role, and sometimes this approach can be ambiguous. So sometimes you can even, let's say, it can give you awkward time because, for instance, person may have a name, but the prototype of a person, which the prototype of the student, which is a person, probably shouldn't have a name because the name belongs to the object of the student. So it's somewhat vague in the specifications what should be placed where. There are many other ways how to implement inheritance in JavaScript. Unfortunately, most of them are wrong. I've just given one example how you can misuse JavaScript properties, JavaScript nature to, let's say, tweak inheritance in a very awkward way. So this one is called parasitic inheritance, and it's based on object augmentation instead of inheritance. I will explain in short order. So again, let's say that we have this person class constructor, which actually is the base class. Again, it has some method called hobby placed to its prototype, and the derived class is actually student. However, in this case, student does not directly inherit from person, meaning it does not share its prototype, but instead it uses new person, creates new object of the base class, and then it augments this object, it shapes this object to a new form, to a new class, so it adds all the necessary things that makes a person student, so it adds necessary methods, and then it yields the new object instead of this object. So note, this variable is not this, it's actually a different variable, and the different variable, different newly created object is replacing the this object, and the this is thrown away. As you can see, this holds many potential pitfalls. First of all, operators like instance of any relationship between the student constructor and the newly created object is completely disrupted. So technically we are not creating a new class, we are just creating a new person which is a slightly different shape than a regular person, and also it has some distinct memory footprint, as we need to recreate everything from the scratch inside the constructor. So for instance, we need to repeatedly recreate the visit course function in this case. So this is just an example how not to proceed in JavaScript. So it's not a good idea to misuse all the things in JavaScript available to tweak the inheritance. So finally, I would like to explain the evolution which took place between this old style constructors and more modern approach directly using prototyping, which I explained earlier. It goes back to the inheritance problem and to the providing objects as prototypes. So let us have a parent class, and we need to create an object of a parent class so we can place it as a prototype of a subclass. This is normally okay, however, sometimes it may cause some problems, especially if the parent class is a very heavy constructor, meaning that the object for the prototype is filled with many potentially unnecessary data, which will be anyway replaced in the subclass. So in this case it may cause some memory issues, especially if we are creating more of these subclasses, because the parent class object has to be created for each derivative class. There is a possible solution. We can use a, let's say, side class, a specific constructor, temporary constructor, which shares the same prototype with parent class. So we basically create a constructor which simulates the parent class, but the constructor itself is empty. It fills no additional things to the newly created objects. Of course, this approach assumes that all the methods are always in prototype, because if some methods are infused inside the constructor itself, so if we have some privileged methods that need to be created repeatedly every time inside the constructor, then this won't work. Then we have to create a slightly different version of this temporary constructor. However, if every method is in the prototype, then this copy of the prototype to the temporary constructor will be sufficient, and then we can use this new temporary constructor as an object creator for our new prototype of the derivative class. In this case, the derivative class will still hold the same prototype chain, so the prototype will point to something that has a prototype of the parent class, so the prototype chain won't be broken. However, the object which resides in the prototype will be much lighter than in the case of regular inheritance, whether you instantiate directly the parent class constructor. We can generalize this approach and create a specific function for this. So we can create a create prototype of, and this function accepts one object, and this object should be a prototype, and it creates a new object which uses O as a prototype. So you can see we just create internal temporary empty constructor, place the O object as the prototype of this constructor, and then instantiate it immediately. Actually, this is pretty much what object create does. So this is like a polyfill. This is like an old implementation of this modern function which you should use now in ECMAScript 5. So we are done with old school constructors, and as a cherry on the top, as a final thing I would like to say in this lecture is object cloning. So object cloning is much more complex than in PHP, for instance, because there is no default way how to ensure object cloning. So you have to be careful about what you really want to achieve. This is just one example how can you achieve object cloning. So first of all, we are implementing it as a function. So first of all, we need to test whether the thing we are trying to clone is actually an object. Yeah, it's a good idea to test your inputs, because in JavaScript you might get anything to be cloned. If it's not an object, you just simply return the value, because probably you are doing something which is not typical. Note that I have to place also object equals null as a guard here, because null of the type of null is also an object, so this won't screen out null values. So the first thing is we need to create a copy into the res value, which is later returned. So we need to create a copy of the object, meaning we need to create a new object with the same prototype as the original. And finally, This is just a for loop which copies all the properties of the own properties of the actual object. You might check out that if we want to perform a deep copy, we need to invoke clone recursively on each copied value. If we're making a shallow copy, we just simply assign the old value into the new object. Actually, this is not the only way. If we are interested only in shallow copies, for instance, there are several other ways. For instance, we can use object assign, which basically assigns values of one object into another object. So we can create new empty object and then use object assign to create the copy. Or we can use some libraries like Lodash, which has this function implemented, but this function is not naturally implemented in the JavaScript library. One other remark, if we are using still old school constructors, then this can be replaced, or maybe even should be replaced, with new object constructor, where the object constructor actually holds the reference to its constructing function. So that's it for this lecture. In the next lecture we will move on and focus on a more modern ECMAScript versions, most importantly ECMAScript 6, because there is a huge difference between ECMAScript 5 and ECMAScript 6. There are some fundamental shifts and many features added. I will also throw a few things from the newer versions, because since ECMAScript 6 the development of this language, of the specifications, took much more rapid pace, and now there is a new version released annually. The release cycle is always in June, so this year also, well, we will see about it because there is this COVID situation, but maybe in June we will get a new version of JavaScript, ECMAScript, now version 11. Actually, the naming now shifts towards release dates, meaning that now we don't have ECMAScript 10 but ECMAScript 219, so it's slightly more convenient to remember. Remember, even though that there are many new versions, and even though that the ECMAScript 6 is already 5 years old, there is nearly 100% support in current browsers. Sometimes when you're dealing with older browsers, when you need to support some older systems, long-term supported systems, or even some Microsoft Internet Explorers, stuff like these, then you need to consider using still ECMAScript 5. Fortunately for you, you can still use newer versions of ECMAScript and then transpile them back to the ECMAScript 5. There are tools for that, tools like Babel, for instance. Thank you for your attention. I hope this video clarified things and not make things even spookier for you. Perhaps it's a good time to relax now and play some video of kittens playing or something. If you have any questions, feel free to write me an email, or possibly you can write a comment beneath this video on YouTube.